Okay, next question. Part A. Basically the same thing again. Ignore this, that's just saying z is a complex number. We want in the form z minus z1 equals r. So we're going to get is z minus 1 plus I equals 3 for now, so we'll graph that. So real, imaginary. We know that this is a circle centered 1, 1, radius 3. So 1, 1 would be over here. So that's 1, 1. It's got a radius of 3, so it'll be something like this. Let's just center that properly on 1, 1. Okay. So it's got a radius of 3. This is going 3 vertical, so this is going to be the point 1, 4. And vertically down, this will be the point 1, minus 2. Okay, so we have drawn that. And again, shading the set of points that satisfy this. Well, the points that satisfy this, again, we want the points to be less than or equal to 3. So if the radius is 3, the points less than or equal to 3 are going to be everything inside the circle. Okay, now let's look at this one. So first of all, we want it in the form z minus z1. So the argument of z minus, so z1 would be basically 2 plus 0i, so we can put 2 plus 0i, and that is, both of these are including, so between pi by 4, whoops, that's fine, and 3 pi by 4. So pi by 4 is 45 degrees, 3 pi by 4 is 135 degrees, okay. So it's going to be a half line from 2, 0. So if this is 1, we'll say this is 2 over here, so open circle at 2, and we have got solid lines, an angle of pi by 4, so 45 degrees. Well, this will be pi by 2, so pi by 4 would be like that. So pi by 4, something like that. Right, now 135 degrees. Let's put it something like this. Let's say it goes through the center. Like that. So what we get is that. Now, like we said, the points that satisfy this is everything inside the circle. And the points that satisfy this is going to be between these two, so it's going to be all of this. Well, what's common is going to be all of this. Right there. There we go. So this is our shaded region over here. Now part B. The complex number w satisfies this. Again, notice it's the same except in terms of w, and we haven't got an inequality. And now this is different. We've still got like something minus 2, but this time it's equal to pi by 4, so it's like similar. So the complex number w satisfies this. Find in the simplest form the exact value of the modulus of w squared. Okay. Right, well we know that this modulus in the form of like w minus w1 is going to be the modulus of w minus 1 plus I equals 3. Well, we know that this is a circle centered 1, 1 with radius 3. Now, because we're going to solve for what w is in like the form x plus iy, where we can find out what x and y are. So we're going to have to find the Cartesian, and then we're just going to find the modulus of that and square it. Well, if we're going to convert to Cartesian, this Cartesian equation will be, so this implies we have x minus 1 squared plus y minus 1 squared equals 3 squared, which is 9. So this is one equation. We'll have another from this, and will be simultaneous equations. Okay, now the next one. So the argument of w minus 2 plus 0I equals pi by 4 is a half line from 2, 0 at an angle of pi by 4, and that's this line over here. So we have to find the equation of this line. It passes through 2, 0 and has pi by 4 as an argument. Well, we have that. This is 2, 0. That's pi by 4. Well, straight away you should know that the gradient is 1. And it passes through this point. So actually using our big boy formula now of y minus y1 equals mx minus x1, you can say that y minus y1, which is y minus 0, is equal to 1, which is the gradient, times x minus x1, which is x minus 2. So our line is y equals x minus 2. Now we have got this and this simultaneous equation. We want to find, but from this question there's only going to be like one w, but we're getting 2x coordinates, so we're going to get 2y coordinates. Why is this? Well, this simultaneous equation over here is the intersection of this line with the circle. So if we draw the full line, if we extend it here, we've got 2 points of intersection. We've got intersection here and an intersection here. So we can clearly see that this x value is going to be more positive compared to this x value, which is going to be more like negated. So we know to reject the negative solution. So we can say it's not 4 minus root 14 over 2. Therefore, x is 4 plus root 14 over 2. And then y, well, we said earlier y is x minus 2, so it's 4 plus root 14 over 2 minus 2. And that's root 14 over 2. So y is root 14 over 2. But we're not finished yet. X is this, y is this. So we can say that w is equal to x plus iy, so 4 plus root 14 over 2 plus root 14 over 2 I. So this is what w is, but we want to find the modulus of w squared. Well, the modulus of w will just be the square root of this squared plus this squared. But we want the modulus of w squared, so we're just going to square all that, so we'll get rid of the square root. So what we just get is the modulus of w squared, so this implies, so therefore the modulus of w squared is equal to 4 plus root 14 over 2 squared plus root 14 over 2 squared, and this is equal to 11 plus 2 root 14. And this is our answer there, 11 plus 2 root 14. Let us check if this is correct. Okay, so the first bit, the same, and then 11 plus 2 root 14, 11 plus 2 root 14. So we have got 5 and 4, we've got 9 marks right there. It's as easy as that. This bit is harder than this bit. This is literally just sketching. You know that this is going to be a circle centered 1, 0 with radius 3. Draw that. You know, these are going to be 2 half lines because we're between 2 angles like that. It's going to be everything between there. So yeah, so these questions look tough, but they are really, really easy. Okay, now let's do one more. So part I. Shade on an Argand diagram the set of points for which the modulus of z minus 3 is less than or equal to the modulus of z plus 6i. Right, so first, if we write this in our z minus z1 form, this is going to be the modulus of z minus 3 plus 0i is less than or equal to the modulus of z minus 0 minus 6i. Now, this is in the form of like modulus of z minus z1 is equal to the modulus of z minus z2, which we know is the perpendicular bisector of the line connecting z1 and z2. So if we shade on our Argand diagram, if we plot this, first let's draw the point 3, 0. So 3, 0 will be here. So let's call that 3, 0. And this is 0 minus 6. So let's say it's somewhere here. That is 0 minus 6. Now if we join these 2 points, and then we get the perpendicular bisector, like that. Let's just make it bisect it, go through the middle, something like this. Draw that to show that it's bisecting perpendicularly. So we'll have to find this point of intersection and this point of intersection. Well, we know that the gradient here is a change in y over the change in x. Well, that's 0 minus minus 6, which is 6 over 3 minus 0, so that's a gradient of 2. So this has a gradient of 2, therefore this has a gradient of minus a half, and it passes through the midpoint over here. So m is minus a half, so if I just write that here, so m equals minus a half. The midpoint of this and this is 0 plus 3 over 2, so 3 over 2, and minus 6 over 2, so minus 3. So the midpoint is that. So therefore the equation of the perpendicular bisector, so perp bisector, that we get y minus y1, so y plus 3 is equal to m minus a half x minus 3 over 2. Right, now we want to find the y-intercept and the x-intercept. Well, the y-intercept is when x equals 0, so what we'll get is x equals 0, we'll get y is equal to minus a half times 0, and minus a half times minus 3 over 2, which is 3 over 4. And then we're minusing the 3, so we're going to get 3 over 4 minus 3, which is minus 9 over 4. So y is going to be minus 9 over 4. And then when y equals 0, that's going to give us the x-intercept. We're going to get x is minus 9 over 2. We're going to get x is minus 9 over 2. So if we label these, so this point is 0 minus 9 over 4. And this point is minus 9 over 2, 0. And okay, and we have to shade the points for which that's that. And now basically this is all equidistant from this point and this point. But we're saying that we want that the points over here to have less of a distance than these points over here. So basically we want everything that's closer to this. Well, everything close to that is just on the top side because that's closer to this point. So everything over here is just going to be shaded like this. Right, so that's part I done, now part II. So determine the exact complex number w which satisfies both of these. Okay, so what we have is the argument of w minus 2 is pi by 3, so that's a half line from w minus bracket 2 plus 0i, so it's going to be from the point 2, 0. So this is the argument of w minus 2 plus 0i is equal to pi by 3, and the argument of w minus 1 plus 0i is equal to pi by 6. Well, what this is saying is that we've got two half lines over here, and w satisfies both of them. So we've got one line over here, one line over here. We basically want them to intersect, and that will be the complex number w that satisfies both of these. So let's just draw a quick sketch. Real, imaginary. Okay, so this point is going to be from 2, 0 and have an angle of pi by 3, which is 60 degrees. So from 2, 0, half line, and it's going to have an angle of 60 degrees or something like this. And then this is going to be a half line from -1, 0, and an angle of pi by 6. So that's going to be -1 half line. So let's just make it something like that. Where this is pi by 6. So we just want to find this point of intersection. Well, first we have to find the equation of this line, and find when they intersect. Okay, so now we just have to find the equation of these lines. So let's start with this one. So let's call it L1. And this is the argument of w plus 1 equals pi by 6. Now, if we had like a triangle over here, right? So that would be the right angle. This would be pi by 6. This would be the x, and this would be the y. Now, we know that the change in y over the change in x is equal to the gradient of the line. Now, of this same line, this x and this y, if we had like a coordinate here and a coordinate here, this distance y over here, so because this is like vertically up, the x stays the same, so it's only going to be the change in y. And the same here, because this is vertical, it's going to be the change in x. So what we can actually say is, because this of the triangle, this is the opposite and the adjacent, we can say that the tan of pi by 6, which is y over x, well, that's the gradient of the line. We're doing the change in y over the change in x, so that's literally the gradient. So the gradient of this line is just tan of pi by 6, which is √3/3. Now, using our formula of y minus y1 equals mx minus x1, what we get is y minus y1, well, we know that it passes through this point, -1, 0, so y minus y1, so that's just going to be y minus 0, is equal to √3/3 x minus -1, which is x plus 1. So this is the equation of the first line. Now the second line, L2, this is the argument of w minus 2 is equal to pi by 3. M is the tan of pi by 3, which is √3. So therefore, from our formula we get y minus, this is 2, 0, so y minus 0, which is y, is equal to √3 x minus 2 is the equation of this line. Well, we've got the two line equations, now we intersect them. Well, they both have y is equal to whatever, so now we just equate. So therefore y is equal to any of these. Let's just do this one. So put in the calculator, so √3 multiplied by 7/2 minus 2, and that's 3√3/2. So this point over here is 7/2, 3√3/2. But the question asks to determine the complex number w. Well, if this complex number w passes through 7/2, 3√3/2, this is going to be w. Well, then w is just going to be, so w we know is going to be x plus iy, which is 7/2 plus 3√3/2i. That's our answer. Now let's check if that is correct. So all of this was shaded, all that was shaded. This is -9/2, and that's -9/4, I'm guessing, which is what we had over here. Yeah, -6 and 3. Perpendicular bisector, all of the shaders, so that's correct. And then part B, 7/2 plus 3√3/2i, 7/2 plus 3√3/2i. So that's also correct. So, 9 marks. hopefully this was helpful. I think as you understand each thing, as you understand what all of this means, as you break it down bit by bit, the big set notation stuff, as you break it all down, just literally just make logic of it. What does this mean? What does this mean? Oh, we have to find where it's common for both. Shade the common area for both. This again, find the common area for both. Break it down bit by bit, and it's quite easy. So I hope this was helpful. Bye.